Hi again. So we're going to take a peek at something called potential energy. And I think back in the seventh grade, you might have learned a little bit about that. And in fact, when teachers generally teach this topic, they always talk about roller coasters because the roller coaster is an excellent teaching tool for teaching about potential energy. So this first video will be pretty short. I'm going to take a few minutes just to explain what potential energy is in terms of like conceptual language, and also basically the formula to go along with it. Okay, so potential energy is basically defined as the ability to do work. So if you look at potential energy, it's the potential ability to do work. It hasn't necessarily done it yet. Okay, so and as we remember, work is defined as the force on an object multiplied by the distance. Here's a situation. Now, to do work, you've got to have some distance and some force. So potential energy conceptually can be understood. I'm going to draw a picture of a big sledgehammer. Okay, here's a sledgehammer of science. Okay, and below the sledgehammer, I've actually started a nail in a piece of wood. Okay, now this hammer can make this nail go a distance into the wood. Okay, it could. If I let this hammer drop, okay, and I applied a force to it, it could do. Come in focus. Okay, it could do work to the nail by sending it a distance. Okay, so force times distance. Okay, that's potential. Okay, that's the potential it has. Now, the higher I lift the hammer, the more potential it has. Okay, so if I were to drop this hammer on my toe from 1 inch, it may not hurt too much. Maybe it'll be a little sting. If I bring it up higher to a foot, it may hurt a lot more. Okay, it's going to do more work. Now, if I lift it up 10 feet and I drop it, you might end up in a hospital. So potential has something to do with height. We'll call this A. Okay, now it also has something to do with how heavy this thing is. So we're going to say mass. Okay, the mass of that thing. And also has to do with what's pulling it down, or what could pull it down, and that we know is gravity. Okay. The higher the mass is lifted, the more work it can do. The higher the mass is lifted, the more work it can do. So when we're talking about potential energy, we're going to give you guys the simple formula for that. Here it is. Potential energy is equal to mass times gravity times height. Those three things we talked about. Mass times gravity times height. And we know that gravity is, okay, we've seen that number 1,000 times in class. But yes, gravity is always going to be that way on Earth. The height, okay, is the height that the object is lifted. And the mass, obviously, is the mass of the object. So I'm going to add in one example of this into this video. I didn't want the video to go this long, but I'm going to do one quick example. Okay, here's my example. And I'm going to tell a story in class, a funny story about a bowling ball that was dropped at a school that caused some problems. But let's use that example here. So let's say I had a bowling ball. Okay, and it dropped 10 meters, and the mass of the bowling ball was 4 kilograms. Okay, and it hit the ground right there. Okay, and I wanted to find out what the potential energy of this would be at this height. All right, so the potential energy we know is mass times gravity times height. Simply, we're going to plug in mass times gravity times the height. Okay, I'll put the height of 10 meters. Okay, let this get in focus. So the potential energy is going to be equivalent to the mass times the gravity times the height. I'd like you guys to figure what that is and put your answer in your notes right there. And our answer is going to be joules. 4 times 9.8 times 10. And the 10 we're actually going to call negative because it is going down. So our potential energy should be a positive number here. Okay, I'll let you guys figure that out. Okay. Thank you and have a great day.